So, say we have this equation, and if you remember back to solving these, I've always told you to set these equations equal to 0. And the reason we do that is because to find the roots, so just going over it, we always set y equal to 0. And I've told you equation equal to 0, but what we're really doing is setting y equal to 0. And the reason for this is if we imagine a graph. So just as a really quick sketch. So if we just take a look at this graph, the reason we've always set our equations equal to 0 and it's actually setting y equal to 0 is because if we look on this graph, if we go to where y equals 0 here, y equals 0 along the x-axis. So if we, by setting y equal to 0, we can find the two roots, the two x points, where the line intercepts the x-axis. And I'll show you what that means. And again, we'll actually be drawing these equations in a future topic, but here I'm just showing you why we actually solve these equations to find the roots of x. So if we went ahead and solved this equation, so we set x squared plus 6x plus 8 equal to 0. And like I just said, the reason we do this, we set y equal to 0 so that we know we're going to be on the x-axis and we can find the points where the x-axis is intercepted. So doing this, we'll have our numbers for our product and our solution. Our product is 8 and our solution is 6. Thinking of two numbers for this, 2 and 4, because 2 times by 4 is 8, and then 2 add 4 is 6. So here are two numbers, and then using this like we normally would, we can do x add 2, and then x add 4, and then this would solve to give us x is equal to minus 2, and x is equal to minus 4. And these points actually have given us our two roots for where the line intersects the x-axis. So because we set y equal to 0. So thinking of this, our coordinates would then be, we know x is minus 2 here and 0 because we set y equal to 0, and we know our coordinates here are minus 4 and 0. So then using this, we actually know now where on the graph we have our roots. Our roots are here at about minus 2, and then here at about minus 4. And then we can actually think of what a graph would look like. It would look something like this. Again,